Hey guys, okay, here's the redo on angles and similar triangles, and hopefully the audio will work the whole time this time. I think maybe I accidentally hit it and shut it off last time. Okay, similar figures. Similar figures have the same shape but may have different sizes. When two figures are similar, they are proportional and the ratios of their corresponding sides are equal. So remember that proportional means that we change at the same rate. Or we multiply or divide by the same number. To get the second figure, depending on which one we start with. Remember, equal also means congruent, which is the same size and same shape. Okay, so are the triangles shown at the right similar? Yes, they are, and it's because corresponding sides, remember corresponding sides is same parts of different figures. So ratios of the corresponding sides, remember ratios of fraction. Okay, ratios of corresponding sides are congruent and sides are proportional. So I will show you how that works here. So this is going to be our original figure. This one will be the new. Okay, we have A and B. I'm going to start with corresponding sides. These are the same parts of different figures. So the 3 and the 1.5 are on the same side of the triangle. Remember, we go from the new to the old, so I'm going to do 1.5 over 3. That's my ratio. And then you can use your calculator to do that division. 1.5 divided by 3, which is going to give you 0.5 or a half. Okay, then I'm going to make a ratio from the corresponding sides of two other sides. I'm going to go with the ones on the bottom. They're both the bottom side of the figure, so it's corresponding sides. We put the new one over the old, so we're going to do 2 over 4. That simplifies to 1/2, and if we do the division, 1 divided by 2, that's also going to put us at 0.5 in decimal form. Okay, ratio out of the third sides, side sets, whatever you want to call them. So these are corresponding sides of different figures. We put the new side over the old side, or the original. So I'm going to put 2.5 over 5. You do the division. 2.5 divided by 5 is still going to give you 1/2. So our sides are proportional because we would multiply or divide the side length of one triangle by 1/2 to get the side length of the other triangle. Okay, down here, circle the two triangles that are similar. What do you notice about their angle measures? Well, when I looked at these, I noticed that these side lengths were the same as this triangle, and these side lengths were the same as this one. So I know, just because I already did the work, that those two triangles are similar to each other. Okay, and what we notice about their angle measures is that their corresponding angle measures are congruent. So this 90 goes with that 90. It's the same. And then we could also say that this 30 goes with this 30. Same parts of different figures, and they have the same measure. Same with the third set. Oops. The 60 degree, same parts, so the right side angle on the right side of the triangle, and they both have the same measure. So if you have two sets of angles, two sets of corresponding angles in your two triangles that you're trying to decide if they're similar, so like the 30, that's one set, and the 90 is a second set. When you have two sets of corresponding angles that are congruent, the same degree measure, the triangles are similar. All you have to do is look at those degree measures to know that the triangles are similar. When you have similar triangles, then you can use the proportions of the side lengths like we did up here to find the missing side lengths of triangles. Only when triangles are similar can we do that. Okay, so on the next page, that's what we're saying. Angle criterion means that if two pairs of corresponding angles in a pair of triangles are congruent, then the two triangles are similar. So it's I just say we need two sets of congruent corresponding angles to prove similarity. Okay, so an example, use the angle criterion to help you answer the following questions. Are the triangles below similar? Why or why not? Well, to prove when I'm given degree measures inside the triangles, I can use that angle criterion to prove that they're similar. I need two sets of congruent corresponding angles. So this angle corresponds with this angle. And this angle, let me do some color. Okay, 58 degrees corresponds with that angle. And then the 35 degree angle on that triangle corresponds with this angle in the other triangle. So the colors kind of help you match your corresponding sides. Excuse me. So I want to know, does this angle have the same degree measure in here as this triangle? Or does this angle match up with that one? I just need one other set of corresponding angles that have the same measure. So I'm going to start with triangle A. So on A, I'm going to, since we know that all angles in a triangle always add up to 180 degrees, all we have to do is add them up and set them equal to 100. So it's going to be 87 plus 58 plus x equals 180. I add these together. That's 15, 13, that's 145. Plus x equals 180. Subtract the 145. X just comes down. We do our math here. So we're going to get 35 degrees is the missing angle in this triangle. And it corresponds with that guy. So now I have two sets of corresponding angles that are congruent. So yes, these are similar. Okay, number 2. Are the triangles below similar? Why or why not? Well, this looks like it corresponds with that angle in the second triangle. Like they're both at the top angle. Then I need to see if any angle in this triangle matches, well, we'd say that one corresponds to that. Or we want to see if there's any angle in this triangle that matches 54. So we want to know if that's 54. So we're going to do the same thing up here. All three angles add up to 180 degrees. So we're going to add those puppies together and see if any of them will match. So starting with the first one, let me go back to purple. So we're going to look at this angle first. So that's a lie. We're going to look at that blue one first. So let me go there. Okay, we're going to find this guy first. So I'm going to add up all three angles. So we're going to do the 60 plus 80 plus x equals 180. That's 14. Add the 0. 180. Subtract 140 from both sides. That makes 0. This guy drops down, and this gives us 40 degrees. So this guy's 40. He doesn't match here. Those are not congruent corresponding angles. So now let's check the 60 and the other triangle. So now let me go to purple. Okay, so now I'm going to work in this triangle and add up those angles. So we're going to do the 80 plus the 54 plus x equals 180 degrees. Add our like terms, so we're going to get 134 plus x equals 180. Subtract the 134. That goes away. Mr. X drops down. And then we do our subtraction here. A little borrowing. Stop it. Okay, I'm going to have to go over here. So x is going to be, that's a 3, that's a 4. 43 degrees, and it does not have the same degree measure. So we only have one set of corresponding congruent angles, which means these are not similar triangles. Only one set of corresponding congruent angles. Okay, we've got Jackie here who's constructed triangle ABC, where A is 53 degrees and angle B is 112 degrees. And then her friend Ruthie went and made a triangle, RST, where S is 112 degrees and T is 15 degrees. Are these similar triangles? Okay, well, we've got one set of corresponding congruent angles. These match. I need one more set. So I need to see if angle C will match up with this little bugger over here. So I'm going to add up the angles and see if the missing one corresponds with an angle over here. Sorry, this one, 15. So 112 plus the 53 plus x equals 180 degrees. Add them up. Plus the x equals 180. Subtract the 165 from both sides of the equal sign. This guy goes away. So this missing angle is 15 degrees and it corresponds with T. So there's our second set of corresponding congruent angles. So these are similar. Two sets of corresponding congruent angles. Okay, so I am going to take a break and stop. This will be the video part 1, the notes. See if you can do 4, 5, 6, and 7. Just do that middle column, the similar, and explain. So just show that the triangles are similar or not, like I have in these 2 or 3 examples. And then in the part 2 video, I will work through all of these examples. So, and then you have just a little mini quiz, and there's one question over this on the mini quiz. This is not really a big deal, so just do your best with all of this, okay? Okay, let me stop this one and then come back to part 2, okay?